Hi everyone, welcome to my video. If you have been following my previous video, you know that I am doing a course on previous year's physics optional men's question paper. So in this video I will discuss physics paper civil service men's paper 2 2019. So you can read this instructions physics paper 2. We know that question number 1 and 5 are compulsory, and out of the remaining 3 are to be attempted. You know that. So come to the points. Constant which may be needed, and section is here. Show that the mass and linear momentum of a quantum mechanical particles can be gives by m is equal to h lambda v and p is equal to h lambda respectively, where h lambda and nu v is nu are Planck constant wavelength and velocity of the particle respectively. Comment on the wave particle duality from these relations. And question number B is state and express mathematicals the three uncertainty principles of Heisenberg, highlight the physical significance of these particles, develop of a quantum mechanics. And question number C is here. For a free quantum mechanical particle under the influence of a one-dimensional potential, so that the energy of quantized in a discrete fashion, how do these energy values differ from those linear harmonic oscillators? One question number D is here. What is population inversion in a general possible in a tool level laser system? Explain it. And question number is, what is Raman active vibration and IR vibration in SO2 molecules complementary to each other? And question number 2 is here. How do you define density of a state so that the density of a star with wave vector less than k in a 3-dimensional cubic box of volume V can be given by? So d omega is equal to V 2 pi square k square dk d omega. In the frequency spectrum omega and omega plus d omega here are assume that number of mode per unit range of k is L is equal to pi, L being the length of each side of a cubic box. And question number B is here. Define mathematicals of both radius of a hydrogen atoms and show that the binding energy of a state N of the atom can be given by. So E n is equal to minus 1 or 2 z e square a z 4 n square pi 1 by 4 pi square pi e epsilon 0, where z is atomic number of hydrogen. Calculate the numerical value of a and e of a hydrogen atom. Question number C. Estimate the size of hydrogen atoms and the ground state energy for the uncertainty principles. Question number 3. Describe the normals and anomalous given effect. Explain how it lifts the density in a hydrogen atom. And question number B is here. What is the lamp shape? Discuss its significance in determining the fine structure of a hydrogen Balmer lines in a hydrogen atoms. And question number C. Define a Pauli spin matrix sigma x, sigma y and sigma z. Using the definition, prove the following. So first, sigma x, sigma square x and sigma square y, sigma square z is equal to 1. Sigma x, sigma y is equal to I iota sigma z I. Sigma z x is equal to iota sigma y, sigma z and I sigma x. So question number 4 is here. Define angular momentum of a particle and find out the three components of the angular momentum operator. L is a Cartesian coordinate. So L square is equal to minus h cut L r square del square minus curly. So del by del x, del by del r square by del r. So prove that the operator L square can be expressed. So L square is equal to minus I h cut minus h cut square 1 by sin theta del by del theta sin theta del by del theta plus 1 by sin square theta del square theta by del phi square in a spherical polar coordinate r theta z, and cylindrical polar coordinate r theta z. So come to the next points. Write down the Hamiltonian operator for a linear harmonic oscillator so that the energy eigenvalue of a sum can be given. En is equal to n plus 1 to h cut omega naught at energy state n, with w being the natural frequency of vibration of the linear oscillator. Prove that the n is equal to 0 energy state has a wave function of typically Gaussian form. And question number C. What are Frank content principle? Discuss the intensity distributions in the vibrational electric spectra of a diatomic molecules on the basis of these principles. And question number section B is here. Question number 5. Stable light nuclei have equal number of proton and neutron, whereas heavy nucleons have excess of a neutron. Explain why. Question: we assume the equal masses for up u and down d quark. Find the ratio un and up of the magnetic moment of a neutron and protons. And question number C. Deduce the Miller indices of a close-packed planes of atoms in the FCC lattice. So Miller indices find S, K, L Miller indices. So the angle between the tetrahedral bonds of a diamond are the same as the angle between the body diagonals of a stack of neighboring cubes having common is and no face. Use vector analysis, find the value of the angles. A semiconductor sample at T 300 Kelvin having a cross-sectional area is 0.5 micrometer square has a pentavalent donor doping profile given by Cx equal to 5 × 10⁻16 E per minus x ln x centimeter cube. Give the mobility of the electron in the samples is 1250 centimeter square. P per minus 1 is per minus 1, and the diffusion length of the electron ln is 4 micrometer. Calculate the diffusion current in the sample at the distance pi is equal to 2 micrometers. And question number 6 is here. This is nuclear physics. Explain the various methods of the finding of the size of the nucleus. How will you determine the nuclear radius for a observations of beta ray resulting from the nuclear transition when inertial and finals nuclei are the mirror of nuclei? Given that the single particle energy separation between 1d 5/2 1d 3/2 in oxygen 17 is a 5 mega electron volt, calculate the strength of a spin orbit interaction is observed 1/d 5/2 level and lower than 1/d 3/2 levels. And question number C is here. Why is it not possible to detect the parity violations in a weak instruction by the observing only the beta decay rate? Justify your answers. And question number 7a. Consider a face-centered cubic lattice of a site. Deduce the primitive translator vectors, the volume of a primitive cell, the reciprocal primitive translation vector, so the volume of the reciprocal lattice. And question number B is here. Derive the expression for the average energy of a quantum oscillations of the frequency P. Assume the Fermi-Dirac distribution E and EF is greater than 2, where EF is the Fermi levels. And question number C. Sketch of the cross-sectional structure of a enhancement mode MOSFET metal oxide semiconductor field effect transistor, and explain its principal operation with the help of its output characteristic. And question number 8 is here. A silicon semiconductor sample is doped with 6 into 10 to the power 16 centimeter cube of aluminum and 7 into 10 to the power 15 centimeter cube of phosphorus atom. Give 30 is equal to 300 Kelvin in transit carrier. Concentration Ni is equal to 1.5 into 10 to the power 10 centimeter cube. The base of the gap is equal to 1.1 electron volt. The electron mobility U micro N 1215 centimeter square V per minus 1 S per minus 1 and the hole's mobility UP 480 centimeter square V per minus 1 S per minus. So determine the sample of the flyings. The types of the semiconductor N and P, N type semiconductor P type, the hole carrier concentrations, the electron carrier concentrations, the position of Fermi level in a sample with respect to the bottoms of the condition band, the conductivity of the samples. And B, a 5 cm cube is a solar cell with a dark reverse saturation current of 2 Na, has a solar radiation incident upon it, producing 4 into 10 to the power 17 electron holes pair per second. The electrons and holes division length are given to be 5 micrometers and 2 micrometers respectively. Calculated for the cell of the flanks, the short circuit current, the open circuit currents. And question number C is here. Explain the origin of the nuclear magnetic moment. Deduce expression for the magnetic dipole moment with the help of the schematics and single particles models. For a system consisting 1 protons and 1 neutron, not necessarily deuteron, write down the various possible states specifying clearly its isospin, spin and orbital quantum numbers. So that is all related to this session. It's for today. Thank you very much and God bless you.